November 24th, 1943, 3:15 in the afternoon, Norfolk Naval Base, Virginia. Captain Joseph J. Clark stood on the deck of USS Wasp, Seavey-18, and watched his ship receive its commissioning pennant. The ceremony was brief, efficient, no speeches, no fanfare, just the reading of orders, the raising of the flag, and the ship officially entering service with the United States Navy. Wasp was a fleet carrier, Essex class, 872 feet long, 27,100 tons displacement, could carry 90 aircraft. Its flight deck could launch and recover aircraft in combat conditions that would ground smaller carriers. Its anti-aircraft batteries could throw up a wall of steel that enemy bombers couldn't penetrate. This was the sixth Essex-class carrier commissioned in 1943, the sixth in 11 months. And it wouldn't be the last. Clark knew the numbers, knew that USS Hornet, CV-12, would be commissioned in 5 days, knew that 9 Independence-class light carriers had also been commissioned this year, knew that American shipyards were producing carriers faster than the Navy could train crews for them. 15 aircraft carriers commissioned in 1943. 15 in a single year. Clark had started his naval career in 1917, had served on battleships and cruisers, had watched the Navy struggle through budget cuts in the 1930s, had seen ships decommissioned because the Navy couldn't afford to operate them. Now, American shipyards were producing 1 carrier every 3 weeks. The transformation was incomprehensible, but Clark also knew what the Japanese were building, had seen intelligence reports, knew that Japan had commissioned 2 fleet carriers during the entire war. 2. Taiho in March 1944 would make 3. But that was it. Japan's carrier force was shrinking while America's was exploding. The mathematics were brutal. America was building carriers 10 times faster than Japan. Actually, 15 times faster if you counted light carriers. The Pacific War would be decided by these numbers more than by any battle. Clark looked at the officers assembled on Wasp's deck. Young men, most in their 20s. They didn't understand yet what they were part of, didn't grasp the scale of American industrial mobilization, didn't know that this ship, this massive fleet carrier, had been built in 18 months from keel laying to commissioning. 18 months to build a ship that displaced more than most pre-war cruisers. That carried more aircraft than some countries' entire air forces. That could project power across thousands of miles of ocean. And America was building them by the dozen. Japan couldn't match this, couldn't even come close. The war was already over. Japan just didn't know it yet. The disparity would be written in burning carriers, in sunken hulls, in the collapse of Japanese naval aviation, in the names of battles, Philippine Sea, Leyte Gulf, the destruction of the combined fleet. But first, someone had to build these ships. The story of American carrier production begins not in 1941, but in 1933, when the United States was broke, when the Navy was small, when the idea of building 15 carriers in 1 year would have seemed like fantasy. The Great Depression had devastated America. Unemployment exceeded 25%. Banks had failed. Factories had closed. Shipyards were empty. The Navy's budget had been slashed repeatedly. Ships were mothballed. Construction programs were canceled. The fleet was aging without replacement. In 1933, the U.S. Navy had 3 aircraft carriers: USS Lexington, CV-2, USS Saratoga, CV-3, and USS Ranger, CV-4. 3. That was the entire American carrier force. Britain had 7. Japan had 4 operational plus 2 under construction. The Naval Expansion Act of 1938 authorized construction of 2 new carriers, USS Hornet, CV-8, and USS Essex, CV-9. The Navy wanted more, but Congress was reluctant. Money was tight. War seemed distant. Europe's problems weren't America's problems. Then came September 1939. Germany invaded Poland. Britain and France declared war. Suddenly, war didn't seem so distant. The Two-Ocean Navy Act of July 1940 authorized massive naval expansion. 11 new fleet carriers, 9 light carriers, dozens of escort carriers, hundreds of other ships. The largest naval construction program in American history. But authorization meant nothing without shipyards, without workers, without materials, without the industrial capacity to actually build the ships. And that capacity didn't exist in 1940. Would have to be created from scratch. Newport News Shipbuilding and Dry Dock Company in Virginia had built Yorktown, CV-5, and Enterprise, CV-6. Was the Navy's primary carrier builder, but Newport News could build only one carrier at a time. The yard had one large dry dock, one set of cranes, one assembly facility. Building a second carrier simultaneously would require expanding the entire yard. The expansion began in 1940. A second building way was constructed. New cranes were installed. The workforce was increased from 11,000 to 31,000. By 1942, Newport News could build 2 carriers simultaneously. Bethlehem Steel's Fore River Shipyard in Quincy, Massachusetts, was brought into carrier production. The yard had built battleships before, but carriers were different, required different designs, different construction techniques, different equipment. Bethlehem's engineers spent months studying Essex-class plans, redesigning their facilities, training workers. By late 1941, Bethlehem was ready to build carriers, would eventually produce 7 Essex-class ships, plus multiple light carriers. The Philadelphia Naval Shipyard in Pennsylvania was expanded. Brooklyn Navy Yard in New York was modernized. New shipyards were considered. But building new yards would take years. The Navy needed carriers now. Existing yards would have to suffice. The workforce was the greater challenge. In 1940, American shipyards employed approximately 75,000 workers. By 1943, that number exceeded 700,000, almost 10 times as many workers. Where did they come from? Everywhere. Men left farms, left factories, left civilian jobs. Women entered the workforce in unprecedented numbers. Rosie the Riveter wasn't just propaganda. Women made up 20 to 25% of shipyard workers by 1943. Welded hulls, riveted deck plates, installed electrical systems, proved they could do the work as well as men. Training was compressed. Traditional apprenticeships lasted years. Wartime training lasted weeks. Workers learned on the job, made mistakes, corrected them, got faster, got better. The quality suffered initially. Early Essex-class carriers had problems, electrical systems that failed, valves that leaked, equipment that didn't meet specifications, but the problems were identified, corrected. Later ships were better. The process improved constantly. Materials were another challenge. An Essex-class carrier required approximately 18,000 tons of steel, plus aluminum, copper wiring, electrical equipment, machinery, Weapons. The material requirements were staggering. American steel production increased from 66 million tons in 1940 to 90 million tons in 1944. The increase alone, 24 million tons, exceeded Germany's entire steel production in 1944, and much of that steel went to shipbuilding. Aluminum production increased even more dramatically, from 206,000 tons in 1940 to 920,000 tons in 1943. Aircraft carriers required thousands of tons of aluminum for aircraft, for superstructure, for equipment, copper production, oil production, rubber production. Every industrial sector expanded. The entire American economy was reorganized for war production, and it worked. By 1943, American shipyards were producing carriers at rates that seemed impossible just 3 years earlier. Commander Minoru Genda stood on the deck of IJNS Taiho and felt pride mixed with despair. Pride because Taiho was magnificent, the most sophisticated carrier Japan had ever built. Armored flight deck, improved damage control, modern radar, advanced aircraft handling systems. Despair because Taiho was alone. The only new fleet carrier Japan had commissioned in 1943. And 1944 wasn't looking much better. Shinano was under construction, converted from a Yamato-class battleship hull. But Shinano wouldn't be ready until late 1944 at earliest. 2 carriers in 2 years, against 15 American carriers in 1 year. Genda was 40 years old in March 1944, had been instrumental in planning the Pearl Harbor attack, had advocated for carrier aviation when most Japanese admirals still believed in battleships, was considered one of Japan's best aviation tacticians, and he knew Japan was losing the production war catastrophically. Taiho represented Japan's best carrier design. The ship was 855 feet long, displaced 37,720 tons when fully loaded. Larger than Essex-class carriers, more sophisticated in many ways. The armored flight deck was 3.1 inches thick over vital areas, could withstand bomb hits that would penetrate Essex-class decks. The armor added survivability, but it also added 1,500 tons of weight, limited aircraft capacity to 75 aircraft instead of 90 plus. Every design choice involved trade-offs. The hangar deck was 510 feet long, narrower than Essex class. Height was limited to 16 feet because of the armored deck above. Could accommodate fewer aircraft, but the hangars could be pressurized, could control damage better through isolation. The design was sophisticated. 3 aircraft elevators serviced the flight deck, 2 on the center line, 1 on the port side. Each could lift 5-ton aircraft. The elevators were hydraulic, fast, reliable. Japanese engineering at its best. The flight deck was 840 feet long, 98 feet wide, larger than Independence class, but smaller than Essex class. No catapults. Japanese carriers relied on long takeoff runs, required the deck to be clear for each launch, slowed operations. But Japanese doctrine didn't emphasize sustained high-tempo operations the way American doctrine did. Armament was heavy. 12 100mm Type 98 dual-purpose guns, 51 25mm Type 96 anti-aircraft guns, 66 13mm machine guns, impressive on paper. But the 25mm guns were inferior to American 40mm Bofors. Lower rate of fire. Less effective fire control. The armament looked formidable, but was less effective in practice. Fire control was manual. No radar direction for the guns. Optical sights only. Japanese gunners were skilled, well-trained. But optical fire control had limitations. Couldn't engage targets beyond visual range. Couldn't fire accurately at night. The Americans' radar-directed fire control was superior. Radar fit was limited. Type 21 air search radar. Type 13 surface search radar. The radars worked, but had shorter range than American systems. Less reliability. Taiho could detect aircraft at maybe 60 to 70 miles. Essex-class carriers could detect at 100-plus miles. The difference gave Americans warning time that Japanese forces lacked. Machinery was powerful. 4 Kampon geared turbines, producing 160,000 shaft horsepower. Maximum speed, 33 knots, same as Essex class. The Japanese machinery was excellent, but fuel consumption was higher. Range was only 8,000 nautical miles at 18 knots, less than half Essex class range. Limited operational flexibility. Fuel capacity, 5,000 tons. Ammunition storage, 250,000 rounds of 25mm ammunition, 400 100mm shells per gun, 200 torpedoes for aircraft. The ship could fight, but resupply was problematic. Japanese logistics couldn't support extended operations the way American logistics could. Crew complement, 1,750 officers and men, plus air group personnel, total approximately 2,400. Smaller than Essex class. Japanese ships were generally less automated, required more manual labor, but still managed with smaller crews through efficiency and harsh discipline. The design reflected Japanese naval philosophy: quality over quantity, sophistication over simplicity, individual excellence over mass production. Taiho was an excellent ship. But Japan needed 20 Taihos to match American carrier strength, and couldn't build them. Genda understood this intellectually, had argued with Navy Ministry officials, had presented production figures, had explained the mathematical reality. But seeing Taiho operational drove the point home emotionally. This magnificent ship, the pride of the combined fleet, the most advanced carrier Japan had built, would be facing 10 or 15 American carriers in the next battle, each American carrier individually less sophisticated, but collectively overwhelming. The numbers from intelligence reports were stark. Japan's carrier force as of March 1944, Taiho, new just commissioned, Zukaku, veteran, sole survivor of Original 6, Shokaku, veteran, damaged but operational, Junyo, conversion, light carrier capability, Hyo, conversion, light carrier capability, Ryuho, conversion, very light capability, Chitos, conversion, a very light capability, Shioda, conversion, a very light capability, Zuiho, conversion, very light capability, total, 9 carriers, but only 3 were true fleet carriers. The rest were conversions with limited capability. American carrier force as of March 1944, 7 Essex-class fleet carriers, operational. 9 Independence-class light carriers, operational. More Essex-class carriers commissioning monthly. Total operational carriers approaching 20. The disparity wasn't just in numbers, it was in sustainability. Every American carrier sunk would be replaced within months. Every Japanese carrier sunk was irreplaceable. The Americans could afford losses. The Japanese couldn't. Genda looked at Taiho's flight deck, watched aircraft being positioned for operations. saw the crews working efficiently, professional, disciplined, the best Japan could produce, and knew it wouldn't be enough. Not against 20 American carriers, not against unlimited American production, not against an enemy that could absorb losses and keep coming. 3 months later, Genda's fears would be realized. Taiho would sink at Philippine Sea, hit by a single torpedo, destroyed by its own aviation fuel vapors igniting, the most sophisticated carrier Japan ever built, lost after 3 months of operation. The disaster wasn't just the ship, it was what the ship represented, Japan's best effort, the culmination of Japanese carrier design evolution, built with tremendous effort over 33 months, lost in 6 hours, and there was no replacement. Nothing coming from Japanese shipyards to make up the loss. Shinano would commission in November 1944. But that would be it. The last fleet carrier Japan would build during the war. Meanwhile, American shipyards were producing carriers monthly. USS Franklin commissioned January 1944. USS Ticonderoga commissioned May 1944. USS Randolph commissioned October 1944. USS Bonhomme Richard commissioned November 1944. The production never stopped. Each new American carrier diluted Japanese strength further, made the numerical advantage more overwhelming, made the strategic situation more hopeless. By the time Shinano commissioned in November 1944, the American carrier force had grown to over 20 fleet and light carriers. The production war was lost. The actual shooting war would continue for another 9 months. But the outcome had been determined in the shipyards. Where America built 15 carriers in 1943, while Japan struggled to complete 2 in 4 years, the numbers were undeniable. Japan had started the war with 6 fleet carriers: Akagi, Kaga, Soryu, Hiryu, Shokaku, and Zuikaku, plus several light carriers, the most powerful carrier force in the world in December 1941. By March 1944, all were gone except Zuikaku. Akagi, Kaga, Soryu, and Hiryu sunk at Midway in June 1942. Shokaku sunk at Philippine Sea in June 1944, which Genda didn't know yet but would happen 3 months later. Only Zuikaku remained from the original 6. Replacements? Taiho was the only new fleet carrier. Several converted light carriers had been commissioned. But these weren't replacements for fleet carriers. They were smaller, carried fewer aircraft, less capable in every way. Why couldn't Japan build carriers faster? Genda knew the reasons, had argued about them with Navy Ministry officials for months. The reasons were systemic, structural, probably unfixable. First, shipyard capacity. Japan had 4 major naval shipyards: Yokosuka, Kure, Sasebo, and Maizuru. All were operating at maximum capacity, building battleships, cruisers, destroyers, submarines, repair work for damaged ships. There simply wasn't enough yard space for massive carrier production. The American solution, build more shipyards, wasn't available to Japan. Building a shipyard required years and enormous capital investment. Japan didn't have years, didn't have the capital, was already straining its resources to maintain existing production. Second, steel. Japan's steel production in 1943 was approximately 7.8 million tons. Sounds impressive until you compare it to American production of 90 million tons. Japan was producing less than 1/10 as much steel as America, and Japanese steel was lower quality, lacked key alloying elements, chromium, nickel, molybdenum. These materials had to be imported. Supply lines were being cut by American submarines. Quality was degrading as alloys became scarce. Third, labor. Japan's industrial workforce was smaller than America's, and it was being depleted. Men were being drafted into the military, sent to fight in China, in the Pacific. The workers remaining were increasingly women, older men, and Korean forced laborers. Forced laborers didn't work well. Productivity was low. Sabotage was common. Quality control was difficult. The labor situation was deteriorating month by month. Fourth, technology. American welding techniques were superior. American cranes were better. American industrial processes were more efficient. Japan relied more on riveting, slower, more labor-intensive. Japanese construction methods were craftsman-based rather than mass production-based. This made individual ships excellent. Japanese naval construction standards were very high, but it made mass production nearly impossible. You can't mass produce craftsmanship. Fifth, resources. Japan lacked everything. Oil from the Dutch East Indies was being interdicted. Iron ore from Southeast Asia was harder to transport as American submarines dominated the sea lanes. Aluminum was scarce. Copper was rationed. Even when materials arrived, transportation within Japan was difficult. Railroads were limited. Trucks were scarce. Moving materials from ports to shipyards to factories was a constant challenge. Sixth, strategic decisions. Japan was fighting on multiple fronts: China, Southeast Asia, the Pacific. Resources were divided. Priorities conflicted. Should steel go to carrier production? Tank production? Aircraft production? Merchant ship production to replace losses? The arguments were endless. Every service branch wanted priority. Every general and admiral claimed their program was most critical. Resources were divided inefficiently. Nothing received full priority. The result? Japan built 2 fleet carriers between December 1941 and December 1944. 2 in 3 years of total war. America built 24 Essex-class fleet carriers in the same period, plus 9 Independence-class light carriers, plus dozens of escort carriers. The disparity was so enormous it defied comprehension. Genda looked at the numbers and saw defeat. Inevitable. Mathematical. Only a matter of time. USS Essex, CI-9, was laid down April 28, 1941, at Newport News Shipbuilding. The keel was positioned. Construction began. The ship that would give its name to the entire class was underway. The construction process for an Essex-class carrier was precisely orchestrated, complex. Involved thousands of workers and hundreds of separate tasks occurring simultaneously. But before construction could begin, the design had to be perfected. And the Essex-class design was revolutionary in ways that aren't obvious from photographs. The Bureau of Ships began design work on the Essex-class in 1939. The requirements were specific: a fleet carrier displacing approximately 27,000 tons, capable of 33 knots, carrying 90-plus aircraft, with armor protection against bombs and torpedoes, with anti-aircraft armament that could defend against massed air attacks. These requirements created conflicts. Speed required powerful engines and sleek hull design, but armor added weight. Aircraft capacity required large hangar decks, but hangar decks created structural weaknesses. Anti-aircraft guns added top weight, but top weight affected stability. The design team spent months balancing these requirements. The final design was a compromise. not perfect in any single dimension, but excellent overall. A design that could be mass-produced while remaining highly effective. The hull design was sophisticated. The underwater form was carefully shaped to minimize drag. The bow was fine-lined for speed. The stern was broad for propeller efficiency. The length-to-beam ratio was optimized for speed while maintaining adequate stability. The Essex-class hull was 872 feet long overall, 820 feet at the waterline. Beam was 93 feet. Draft was 28 feet when fully loaded. These dimensions gave the ship excellent speed characteristics. The hull could move through water efficiently at high speeds, without excessive power requirements. The armored belt along the waterline was 4 inches thick. Not enough to stop battleship shells, but adequate against cruiser guns and torpedo impacts. The armor extended 14 feet below the waterline and 6 feet above, protected the machinery spaces and magazines. The flight deck armor was minimal, 1.5 inches over magazines. No armor over most of the deck. This was a conscious decision. Armored flight decks like Taiho's added 1,500 tons. The Americans chose to use that weight for additional aircraft instead. More offensive capability rather than more protection. The hangar deck was massive, 654 feet long, 70 feet wide, 17.5 feet high. Enough space to service and repair aircraft under cover. The hangar was serviced by 3 aircraft elevators, 2 on the center line, 1 on the starboard deck edge. Each elevator could lift a fully loaded aircraft from hangar to flight deck in 15 seconds. The flight deck itself was revolutionary, built with a 7-degree forward slope. This slope improved aircraft takeoff performance, allowed heavier loads. The deck planking was 3-inch Douglas fir over steel supporting structure. The wood provided good traction, absorbed shock when aircraft landed hard, but it was flammable. Combat experience would show this was a weakness. Catapults were installed at the bow. 2 H-4B hydraulic catapults. Each could launch a 15,000-pound aircraft at 85 miles per hour. The catapults were essential for launching heavily loaded strike aircraft, allowed full offensive loads without requiring long takeoff runs. Arresting gear was sophisticated. 8 arresting wires across the after portion of the flight deck. Each wire connected to hydraulic cylinders that absorbed the aircraft's momentum. The system could stop a 15,000-pound aircraft landing at 80 miles per hour in 325 feet. The arresting gear worked, but it required constant maintenance. Wires broke, cylinders leaked. Keeping the system operational required dedicated crews working constantly. The island superstructure was compact, only 158 feet long, 35 feet wide, housed the bridge, flight control, radar rooms, chart rooms, and communication centers. The island was positioned for optimal visibility. The bridge had unobstructed views forward, to port, and to starboard. Flight control could see the entire flight deck. Radar was critical. Essex-class carriers were equipped with the latest radar systems. SK Air Search Radar could detect aircraft at 100 miles. SM Height Finding Radar could determine altitude. SG Surface Search Radar could detect ships at 15 to 20 miles. SC Radar provided backup air search capability. The radar fit gave Essex-class carriers awareness that Japanese carriers couldn't match. Fire control systems integrated radar with gun directors. The Mark 37 director for the 5-inch guns used radar tracking, could engage targets beyond visual range, could fire accurately at night or in poor visibility. The fire control was semi-automatic, far superior to the manual systems on Japanese carriers. Anti-aircraft armament was formidable and constantly upgraded. Initial fit: 12 5-inch 38 caliber dual-purpose guns, 32 40mm Bofors guns in quad mounts, 46 20mm Oerlikon cannons. By 1945, some Essex-class carriers had over 80 40mm guns and 60 plus 20mm guns. The ships bristled with AA weaponry. The 5-inch guns were versatile, could engage surface targets, could engage aircraft. Rate of fire: 15 rounds per minute. Range against aircraft: 37,000 feet vertical. Guns were radar directed, could put up an accurate barrage that enemy bombers couldn't penetrate. The 40mm Bofors was the primary close-range AA weapon. 4 guns per mount, 8 quad mounts. Rate of fire: 120 rounds per minute per gun, 480 rounds per minute per mount. The Bofors created a wall of steel at ranges of 2,000 to 4,000 yards. Effective ceiling: 22,000 feet. Any aircraft entering Bofors range faced almost certain destruction. The 20mm Oerlikon was the last-ditch defense. Single mounts, manually aimed. Rate of fire: 450 rounds per minute. Effective range: 1,000 yards. When aircraft got through the 5-inch and 40mm defenses, the 20mm guns were the final barrier. Fast-firing, deadly at close range. Machinery was powerful and reliable. 4 Westinghouse-geared turbines, each driving one of 4 propeller shafts. The turbines were connected to reduction gears. Step down the turbine speed to propeller speed. The system was efficient, quiet, reliable. Steam came from 8 Babcock and Wilcox boilers, 2 boiler rooms, 4 boilers per room. The boilers burned fuel oil, produced superheated steam at 565 pounds per square inch and 850 degrees Fahrenheit. The steam drove the turbines at thousands of RPM. The reduction gears brought this down to propeller speed of approximately 200 RPM. Total shaft horsepower: 150,000. Maximum speed: 33 knots. But the ships could sustain 30 knots for extended periods, could maintain 25 knots almost indefinitely. The machinery was over-engineered, reliable, could take battle damage and keep running. Fuel capacity was 6,330 tons. Range at 15 knots, 20,000 nautical miles. The Essex class could cross the Pacific, operate for weeks, return without refueling. The endurance was critical for Pacific operations or where distances were enormous. Crew complement was large, 2,600 officers and enlisted personnel, plus air group personnel, another 500 to 800 men. Total, approximately 3,400 men aboard. The crew size reflected the ship's complexity, required constant maintenance. Constant operations, constant vigilance. Living conditions were cramped. Enlisted men slept in berthing compartments, stacked bunks, limited personal space. Officers had tiny cabins, usually shared. The ship was crowded, noisy, hot in tropical climates, uncomfortable, but functional. Damage control was extensive. The ship was divided into zones. Each zone had dedicated damage control teams. Firefighting equipment, portable pumps, shoring materials. The crew trained constantly, practiced fighting fires, practiced controlling floods, practiced repairing battle damage. The design worked. Essex-class carriers were tough, could absorb damage and survive. USS Franklin, CV-13, was hit by 2 bombs in March 1945. The bombs penetrated the flight deck, exploded in the hangar, started massive fires, detonated armed aircraft. Over 800 men were killed. The ship was devastated, but it didn't sink. The crew controlled the damage. Franklin made it back to port under its own power. USS Bunker Hill, CV-17, was hit by 2 kamikazes in May 1945. The aircraft struck the flight deck, started massive fires, killed 393 men. The ship was burning, but the crew fought the fires, controlled the flooding. Bunker Hill survived, was repaired, returned to service. These survival stories validated the design. The Essex class could take punishment that would sink lesser ships. The damage control systems worked. The compartmentalization contained flooding. The firefighting equipment controlled fires. The ships were tough, and America was building them by the dozen. 24 Essex-class carriers completed before war's end, with more under construction when Japan surrendered. The production was relentless, overwhelming, unstoppable. The keel was laid first, steel I-beams forming the ship's spine, then framing began. Steel ribs rising from the keel, defining the hull shape. These frames were massive, each weighing several tons, positioned with precision, welded together. Then came hull plating, steel sheets, 20 to 30 feet long, positioned against the frames, welded edge to edge. The welding was critical. Bad welds meant leaks, meant structural weakness, meant potential failure in combat. Newport News employed thousands of welders. They worked in teams. One welder would start a seam, another would follow, checking, correcting imperfections, a third would inspect. Quality control was constant. The hull took shape over months, the distinctive lines of a fleet carrier emerging, long, sleek, designed for speed and efficiency in the water. Internal structure was built simultaneously, compartments, bulkheads, watertight doors. An Essex-class carrier had over 2,000 compartments, each serving specific purposes: storage, crew quarters, workshops, magazines, fuel tanks. The interior was a maze of steel corridors and spaces. The hangar deck was constructed, a massive open space occupying much of the ship's interior, where aircraft would be stored, maintained, prepared for launch. The hangar had to be strong enough to support aircraft weight, large enough to hold 90-plus aircraft, with overhead cranes for moving aircraft, with workshops for repairs. The flight deck was built last, the most distinctive feature of any carrier. On Essex-class ships, the flight deck was wooden planking over steel supporting structure. The wood provided better traction for aircraft, better shock absorption when aircraft landed. But it was also flammable, a trade-off. Speed of construction and operational effectiveness versus fire safety. The flight deck on Essex was 862 feet long, 108 feet wide at its widest point, enough space to launch and recover multiple aircraft simultaneously. Catapults were installed for assisted takeoffs, arresting gear for landings. The deck was designed for maximum efficiency in combat operations. The island superstructure rose on the starboard side: command center, bridge, flight control, radar, communications. The island was compact, positioned to minimize interference with flight operations while providing optimal visibility. Armament was installed continuously: 5-inch dual-purpose guns, 40mm Bofors anti-aircraft guns, 20mm Oerlikon cannons. By 1943, Essex-class carriers bristled with anti-aircraft weapons. Lessons from combat had shown that carriers faced their greatest threat from enemy aircraft. The AA armament reflected that reality. Machinery was installed below decks: 4 Westinghouse geared turbines, producing 150,000 shaft horsepower, driving 4 propeller shafts, giving the Essex class a top speed of 33 knots. Fast enough to keep up with cruisers, fast enough to escape threats, fast enough to close on targets. The boilers required to generate steam for the turbines were massive: 8 Babcock and Wilcox boilers, each standing 2 decks high, fired by fuel oil, producing superheated steam at enormous pressure. The engineering spaces were hot, noisy, dangerous. But they gave Essex its power. Electrical systems were extensive: generators, distribution panels, wiring throughout the ship. An Essex-class carrier required enough electricity to power a small city. Lighting, equipment, elevators, radars, radios, computers, everything ran on electricity. From keel laying to launching took approximately 12 months for early Essex-class ships. Essex itself was launched July 31st, 1942. 14 months after construction began, still incomplete. But the hull was finished enough to float. Fitting out occurred at the dock, installing remaining equipment, testing systems, training crews. This process took another 6 to 8 months. Essex was commissioned December 31st, 1942. 20 months from keel laying to commissioning. Essex-class carriers were impressive, but building them took time. 18 to 20 months even, with experienced yards working efficiently. The Navy needed carriers faster, needed them now, needed a rapid production solution. The answer was the Independence-class light carrier, built on cruiser hulls, converted during construction. A compromise, not as capable as fleet carriers, but faster to build, and available in numbers when numbers mattered most. The Independence-class story began in January 1942, just weeks after Pearl Harbor. President Roosevelt wanted more carriers immediately. The Essex-class program was underway. But those ships wouldn't be ready until late 1942 at earliest. Roosevelt demanded faster production. The Navy proposed converting Cleveland-class light cruiser hulls. 9 cruisers were under construction. Their hulls could be modified, flight decks installed, aircraft facilities added. The conversion would be faster than building fleet carriers from scratch, could produce operational carriers in 12 to 15 months instead of 20 months. Roosevelt approved. The conversion program began immediately. USS Amsterdam, CL-59, was under construction at New York Shipbuilding in Camden, New Jersey. The hull was 75% complete when work stopped in March 1942. The ship was redesignated CVL-22, named Independence. Construction resumed as a light carrier. The conversion was extensive. The cruiser superstructure was removed. A hangar deck was built atop the hull. A flight deck was installed above the hangar. The original cruiser machinery remained. 4 boiler rooms, 4 turbines, same propulsion system. But everything above the main deck was rebuilt for carrier operations. The flight deck was 552 feet long, much shorter than Essex class, only 73 feet wide, narrow. The deck could accommodate smaller aircraft, couldn't operate heavy bombers, but could operate fighters and light attack aircraft effectively. The hangar deck was even more constrained, only 268 feet long, 46 feet wide, 17 feet high, could hold approximately 30 aircraft, less than one-third the capacity of an Essex-class carrier, but still significant striking power. 2 aircraft elevators serviced the hangar, both on the center line, could lift aircraft from hangar to flight deck quickly. The elevators were smaller than Essex-class elevators, but adequate for the aircraft the Independence class would operate. Catapults. None initially. The flight deck was long enough for unassisted takeoffs. Later ships received 1 hydraulic catapult. This allowed launching more heavily loaded aircraft, but most operations relied on free takeoff runs. Arresting gear, 4 wires, same hydraulic system as Essex class, could recover aircraft safely despite the shorter deck. The landing area was tight, required skilled pilots, but it worked. Armament was reduced compared to Essex class. 2 5-inch/38 guns, 16 40mm Bofors in quad mounts, 22 20mm Oerlikon cannons, less firepower than fleet carriers, but still formidable anti-aircraft capability. The armor was cruiser armor, not optimized for carrier operations. 3-inch belt, 2-inch deck. Better protection than Essex class in some ways, but the narrow hull and high center of gravity created stability problems. The ships rolled excessively in rough seas, affected flight operations, affected crew comfort. Speed was excellent, 32 knots. Slightly slower than Essex class, but faster than most Japanese carriers. The cruiser machinery was powerful, reliable. The Independence class could keep up with fast carrier task forces. Range was limited, 13,000 nautical miles at 15 knots. Adequate for Pacific operations, but less than Essex class. Required more frequent refueling. The smaller fuel capacity reflected the cruiser origins. Crew size was smaller, 1,500 men total, including air group. More compact than Essex class, reflected the smaller size, less capable in some ways, but required fewer personnel to operate. Construction time was a critical advantage. USS Independence commissioned January 1st, 1943. Just 10 months after conversion began. USS Princeton commissioned February 25th, 1943. USS Belleau Wood commissioned March 31st, 1943. The production was rapid. All 9 Independence-class light carriers commissioned in Mata den 1943. USS Independence, CVL-22. January 1st, 1943. USS Princeton, CVL-23. February 25th, 1943. USS Belleau Wood, CVL-24. March 31st, 1943. USS Cowpens, CVL-25. May 28th, 1943. USS Monterey, CVL-26. June 17th, 1943. USS Langley, CVL-27. August 31st, 1943. USS Cabot, CVL-28. July 24th, 1943. USS Baton, CVL-29. November 17, 1943. USS San Jacinto, CVL-30. December 15th, 1943. 9 carriers in 1 year, all from converted cruiser hulls. The production was exactly what Roosevelt had demanded. More carriers, faster, available when needed most. The Independence class wasn't perfect. The narrow hull and high top weight caused stability problems. The ships rolled heavily. In rough seas, flight operations became dangerous. Aircraft could slide across the sloped deck, crash into parked aircraft. The deck crews had to be careful. The limited aircraft capacity meant less striking power. An Essex-class carrier could launch 40 to 50 aircraft for a single strike. An Independence class could launch maybe 20 to 25. Half the capability, but still significant when multiple carriers operated together. The lack of armor protection made them vulnerable. The flight deck had no armor. A single bomb hit could penetrate to the hangar, start fires, cause catastrophic damage. USS Princeton was sunk at Leyte Gulf by a single Japanese bomb hit the detonated aircraft in the hangar. The ship was destroyed in 3 hours, but the Independence class served effectively. They operated in every major Pacific campaign, supported landings, conducted airstrikes, provided fighter cover. The ships proved their worth despite limitations. The key was numbers. 9 carriers available in 1943. When combined with 6 Essex-class carriers, America commissioned 15 carriers in 1 year. The production surge came at exactly the right time, when American forces were moving from defensive to offensive operations, when carriers were needed for island-hopping campaigns across the Pacific. The Independence class filled the gap, provided carrier capability while Essex-class production ramped up, allowed the Navy to form multiple carrier task groups, to operate simultaneously in different areas, to maintain constant pressure on Japanese forces, and they were built fast, faster than any other carrier class, 10 to 12 months from conversion start to commissioning. The rapid production demonstrated American industrial flexibility, the ability to adapt, to find solutions, to produce what was needed when it was needed. Japan had no equivalent, couldn't convert merchant ships or cruiser hulls into carriers quickly. Tried a few conversions, but they were slow, required extensive modifications. Took as long as building new carriers. Japan's industrial structure couldn't match American flexibility. The result? America had 15 new carriers in 1943. Japan had maybe 2. The production disparity was overwhelming, and it would only get worse as 1944 progressed. Newport News was producing 2 Essex-class carriers simultaneously by 1943. Bethlehem Quincy was producing them almost as fast. The yards were hitting their stride. Workers knew what they were doing. Mistakes decreased. Efficiency increased. But even with improvements, building a fleet carrier was an enormous undertaking, required approximately 2 million man-hours of labor, thousands of tons of materials, hundreds of complex systems, all integrated into a functioning warship, and America was doing it 15 times in 1943 alone. The scale was unprecedented, unmatched, probably unmatchable. Japan's carrier construction faced challenges American builders never encountered. The challenges were technical, logistical, strategic. They accumulated, compounded, made rapid production nearly impossible. Taiho's construction illustrates the problems. The ship was laid down July 10, 1941, at Kawasaki Shipyard in Kobe. Was Japan's first carrier designed with an armored flight deck. The armor would protect against bomb hits, would prevent bombs from penetrating to the hangar deck, would make the carrier more survivable. But armored flight decks were heavy. Taiho's deck armor was 80 millimeters thick over vital areas. This added approximately 1,500 tons to the ship's weight, required strengthening the hull structure, required more powerful engines to maintain speed despite the extra weight. The design was sophisticated, probably the most advanced carrier design of the war. But sophistication meant complexity. Complexity meant longer construction times. Taiho's construction took 33 months from keel laying to commissioning. Nearly 3 years. Essex-class carriers were averaging 18 months. Japan was taking twice as long to build each carrier. Why? Several factors. Material shortages slowed construction repeatedly. Steel deliveries were delayed. Armor plate had to be manufactured to exact specifications. Japanese steel production couldn't always meet demand. Construction would halt for weeks waiting for materials. Labor quality declined as experienced workers were drafted. Replacements were less skilled, worked more slowly, made more mistakes. Quality control required more oversight, more rework. Everything took longer. Design changes during construction disrupted schedules. Lessons from combat were incorporated into ships under construction. Radar systems were upgraded. Anti-aircraft armament was increased. Damage control systems were improved. Each change required redesigning parts of the ship, remanufacturing components, installing different equipment. The changes improved the final product, made Taiho more capable, but they extended construction times significantly. Strategic bombing didn't affect Japanese shipyards until late in the war, but the threat diverted resources, anti-aircraft defenses, shelters, dispersion of facilities. These measures consumed materials and labor that could have gone to shipbuilding. The biggest factor was simply scale. American shipyards were building multiple carriers simultaneously. Newport News had 2 ways. Bethlehem had 2 ways. 4 Essex-class carriers could be under construction at once just at those 2 yards. Japanese yards couldn't match this. Kure Naval Arsenal was building Taiho, also building battleship Yamato, also building cruisers and destroyers. The yard was enormous, but couldn't expand indefinitely. Space was limited. Resources were limited. When Taiho was completed in March 1944, it was alone. No other fleet carriers were near completion. Shinano was still months away. Japan's carrier force consisted of Taiho, Zuikaku, and several smaller carriers. America at the same time had operational Essex, Yorktown, Intrepid, Hornet, Lexington, Bunker Hill, Wasp, Hancock, plus 9 Independence-class light carriers, 18 carriers, and more launching monthly. The production disparity translated directly to combat power. More carriers meant more aircraft, meant more strikes, meant more flexibility, meant the ability to sustain operations despite losses. Japan couldn't sustain losses. Every carrier sunk was irreplaceable. Every pilot killed was irreplaceable. The Americans could afford attrition. The Japanese couldn't. This reality would be demonstrated at Philippine Sea in June 1944 and at Leyte Gulf in October 1944. Battles where American numerical superiority was so overwhelming that Japanese tactical skill was irrelevant. The Battle of the Philippine Sea occurred June 19th to 20th, 1944, called the Great Marianas Turkey Shoot by American pilots. The battle demonstrated what happened when American production met Japanese desperation. The Japanese mobile fleet had 9 carriers: Taiho, Zuikaku, Shokaku, Junyo, Hiyo, Ryuho, Chitose, Chiyoda, and Zue. 9 carriers carrying approximately 430 aircraft. This was Japan's maximum carrier strength, everything they could scrape together. The American Fifth Fleet had 15 carriers, 7 Essex-class fleet carriers, and 8 Independence-class light carriers, carrying over 900 aircraft. The Americans had almost twice as many carriers, more than twice as many aircraft. The battle opened with Japanese airstrikes, waves of aircraft attacking the American fleet. They were met by hundreds of American fighters, Grumman F-6F Hellcats, purpose-designed to kill Japanese aircraft, faster than Zeros, better armed, better protected, flown by well-trained pilots. The slaughter was one-sided. Japanese aircraft were shot down by the dozens. American pilots reported targets were so numerous they could hardly miss. Over 300 Japanese aircraft were destroyed in the first day. American losses, fewer than 30 aircraft, but the carrier losses were worse. Taiho was hit by a single torpedo from submarine USS Albacore. The damage seemed minor initially, but aviation fuel vapors accumulated in the hangar. 6 hours after the torpedo hit, the vapors ignited. A massive internal explosion ripped Taiho apart. The ship sank. Japan's newest, most sophisticated carrier, gone. Shokaku was hit by 4 torpedoes from USS Kavala. The damage was catastrophic. Shokaku sank 3 hours later. Another of Japan's original 6 fleet carriers, lost. And Hio was sunk by American carrier aircraft in the late afternoon of June 20th, struck by torpedo and bomb hits, sank that evening. 3 carriers lost in 2 days. Japan's carrier strength was devastated. 6 carriers remained, facing 15 American carriers. The disparity was now overwhelming. The Americans lost 0 carriers. 0. Not even damaged. The F-6F fighters had created a defensive umbrella that Japanese attackers couldn't penetrate. After Philippine Sea, Japan couldn't replace the losses. The 3 carriers sunk represented years of construction, thousands of workers, enormous material investment. They were gone, and nothing was coming to replace them. America, by contrast, was still producing carriers. USS Franklin, CV-13, was commissioned January 1944. USS Ticonderoga, CV-14, in May 1944. USS Randolph, CV-15, in CUNT, October 1944. USS Shangri-La, CV-38, in September 1944. The production continued without pause. By October 1944, when the Battle of Leyte Gulf occurred, the disparity was even worse. Japan committed 4 carriers to the battle: Zuikaku, Zuiho, Chitose, and Chiyoda. All 4 were sunk. The entire carrier force destroyed in one battle. American losses at Leyte Gulf: USS Princeton, CVL-23, a light carrier. 1 ship against 4 Japanese carriers sunk. After Leyte Gulf, Japan had no operational carriers. None. The carrier force that had dominated the Pacific in early 1942 was extinct, destroyed through combat and irreplaceable losses. America had 17 fleet carriers operational in November 1944, plus dozens of light carriers and escort carriers. The production advantage had been translated into overwhelming combat superiority. The human story behind the production numbers was extraordinary. The workers who built these ships, the engineers who designed them, the managers who organized production. They transformed American industrial capacity in ways that shaped history. A typical shipyard worker in 1943 was unlikely. Often female, often young, often with no previous shipbuilding experience. They learned on the job. made mistakes, improved, became skilled. Consider Newport News Shipbuilding in 1943. The workforce had grown from 11,000 in 1939 to 31,000. The expansion came from everywhere. Farm boys from Virginia and North Carolina, women from cities who'd never worked in industry, black workers from the South seeking better wages, older men who'd worked in other trades, young people fresh out of high school. They worked 3 shifts, 24 hours per day, 7 days per week. The shipyard never stopped. Lights blazed at midnight. Welders sparked at 3 a.m. Cranes moved at dawn. The work was relentless. A typical shift. Report at 7 a.m. Receive work assignments. Gather tools. Walk to your section of the ship under construction. Climb aboard via temporary. Scaffolding. Find your work area. Begin welding, or riveting, or installing equipment. Work until 11:30 a.m. break. Eat lunch. Resume work at noon. Work until 3:30 p.m. Take another break. Work until shift end at 5 p.m. 10 hours with 2 breaks. 6 days per week. Sometimes 7 when production schedules were critical. The pay was good. Welders earned approximately $1.20 per hour. Riveters earned $1.10. General laborers earned 90 cents. With overtime, weekly earnings could reach $60 to $70. Substantial money in 1943. Enough to support a family. Enough to save for the future. But the work was demanding. Welding in July inside a steel hull was hellish. Temperatures exceeded 100 degrees Fahrenheit. The metal radiated heat. The welding torch added more. Welders worked in short bursts. 15 minutes. Rest. 15 minutes more. Hydration was critical. Men collapsed from heat exhaustion regularly. Winter welding was different, but equally difficult. The steel was cold. Hands numbed. Welding rods didn't flow as smoothly. Quality suffered. Work slowed. But production schedules didn't change. The ships had to be built. The workers adapted. Women welders became common. Before 1941, shipyard welding was exclusively male. By 1943, women made up 15 to 20% of welders at major yards. They proved they could do the work as well as men, sometimes better. Smaller hands could access tight spaces. Attention to detail produced cleaner welds. Many supervisors preferred female welders for precision work. Josephine Casey worked at Bethlehem Steel's Four River Shipyard in Quincy. Started in October 1942. No previous experience. Went through 6-week welding school. Was certified in December. Spent the next 3 years welding carrier holes. Her specialty was bulkhead seams. The vertical walls separating compartments. The seams had to be perfect. Watertight. Able to withstand water pressure if the ship flooded. Casey's seams were tested constantly. Random inspections, hydrostatic testing. Her work always passed. She was proud of that. Casey worked the night shift, 11 p.m. to 7 a.m. Preferred it. Fewer supervisors around. More autonomy. She could focus on her work, could take pride in clean seams, could know that her welds might save lives in combat. She earned $1.30 per hour. With a night shift differential and overtime, she made $75 to $80 per week. More than her father made as a store clerk. More than most women could earn in any other job. The money was good, but the purpose was better. She was building ships that would win the war. African American workers found opportunities in shipyards that were closed elsewhere. Segregation remained. Black workers often got the worst jobs, the hottest areas, the most dangerous tasks, the lowest paying positions, but they could work, could earn wages, could support families. James Williams worked at Newport News, started in May 1942, was assigned to the hot riveting gang. The work involved heating steel rivets to red-hot temperatures in portable furnaces, then quickly driving them through aligned holes in steel plates. The work was hot, dangerous, exhausting. The riveting gang worked in the engine rooms and boiler spaces, the deepest, hottest parts of the ship, where ventilation was poor, where temperatures exceeded 110 degrees Fahrenheit in summer, where the clanging of hammers was deafening. Williams hated it, but the pay was 95 cents per hour. Better than sharecropping in Alabama. Better than any job available to black men in the rural South. Williams worked at Newport News for 3 years, helped build 6 Essex-class carriers, took pride in his work despite the conditions, knew his rivets held steel plates that protected sailors, knew he was contributing to victory. That mattered. After the war, Williams tried to stay at Newport News, but jobs were cut. Returning white servicemen got priority. Black workers were laid off first. Williams left shipbuilding, returned to Alabama, worked as a construction laborer. But he remembered the war years, the sense of purpose, the contribution to something larger than himself. Engineering challenges were constant. The Essex-class design was complex. Thousands of systems had to integrate: electrical, mechanical, hydraulic, fire suppression, damage control, ventilation, refrigeration. Everything had to work together, had to be installed correctly, had to be tested before the ship commissioned. Robert Henderson was an electrical engineer at Newport News. His team designed and installed electrical systems on Essex-class carriers. The work was meticulous. Each carrier required 500-plus miles of electrical cable, thousands of junction boxes, hundreds of electrical panels, thousands of circuit breakers and switches. Henderson's team had to route cables through compartments, avoid interference with other systems, ensure proper insulation, test every circuit for continuity, and correct voltage. The work took months per ship. Any mistakes could cause failures in combat. The responsibility was enormous. Henderson worked 70-hour weeks regularly, 6 days of 12 hours, sometimes 7 days when deadlines loomed. He was salaried, no overtime pay, but felt the work was worth it. Each carrier successfully commissioned validated his team's work. Each ship that survived combat proved the electrical systems functioned under the worst possible conditions. Supply chain management was another challenge. An Essex-class carrier required thousands of different components, many from specialized suppliers, propeller shafts from Bethlehem Steel, reduction gears from General Electric, boilers from Babcock and Wilcox, catapults from Westinghouse, radar from RCA and Western Electric. Coordinating delivery of all these components required careful planning. Components had to arrive when needed, not too early. Storage was limited, not too late. Construction schedules were tight. Supply chain managers worked constantly to balance these requirements. Rail transportation was critical. Components came from factories across the country: Pennsylvania, Ohio, Connecticut, New York, all shipped by rail to shipyards. The railroads were overwhelmed. Military freight had priority, but carrier components competed with everything else the military needed. Delays were common. Supply chain managers had to improvise constantly. Mary Patterson worked as a procurement specialist at Bethlehem Quincy. Her job was tracking component deliveries, ensuring parts arrived on schedule, expediting shipments when delays occurred, working with suppliers to maintain quality while increasing production. Patterson managed procurement for radar systems. The components came from multiple suppliers, transmitters from one factory, receivers from another, antennas from a third, display consoles from a fourth. All had to arrive and be installed in proper sequence. Any delay disrupted the schedule. Patterson worked with suppliers across the country, placed orders months in advance, tracked production, arranged transportation, solved problems when components were delayed or defective. The work was stressful, required constant communication, required understanding of both technical requirements and industrial logistics. She took pride in her role, knew that radar saved lives, could detect enemy aircraft before they became visual threats, could direct fighters to intercept, could protect the fleet. Her procurement work contributed to that capability. The connection between her desk work and combat effectiveness was clear. Quality control was paramount. Every weld had to be tested. Every rivet had to be inspected. Every electrical connection had to be verified. The lives of 3,000 plus men depended on this ship being built correctly. Inspectors worked constantly, checking welds with X-rays, testing for cracks, measuring to ensure dimensions match specifications, rejecting work that didn't meet standards. The inspectors were not popular with production workers, but they were essential. Bad welds had to be cut out and re-welded, cost time and money. But the alternative, welds failing in combat, was unacceptable. The inspection standards were strict, were enforced rigorously. Quality couldn't be compromised to meet schedules. The shipyard managers had to balance competing demands. Roosevelt wanted carriers fast. The Navy wanted carriers that worked. Workers wanted reasonable schedules. Suppliers wanted clear requirements. Everything had to be balanced. The managers who succeeded were those who could organize complexity, could coordinate thousands of workers, could maintain quality while increasing speed, could solve problems creatively, could keep production moving despite endless obstacles. Homer Ferguson was president of Newport News Shipbuilding during the war. He managed the yard's transformation, the workforce expansion, the facility improvements, the production acceleration. Under his leadership, Newport News built 10 Essex-class carriers, more than any other yard. Ferguson was an engineer by training, understood ship construction, knew what was technically possible, knew where compromises could be made and where they couldn't. His technical knowledge, combined with management skill, made him extraordinarily effective. He worked from 7 a.m. to 9 p.m. most days, 6 or 7 days per week, visited the yard daily, talked to workers, listened to problems, made decisions quickly. His visible presence boosted morale. Workers knew management cared about their work, knew their efforts were recognized, felt they were part of something important. The shipyard culture during the war was unique. Everyone understood the urgency, understood that these ships would fight, that sailors would depend on them. That victory required maximum effort. This shared sense of purpose created cohesion that overcame many difficulties. Workers tolerated long hours because the work mattered, accepted difficult conditions because the purpose was clear, took pride in their contribution even when individual. Tasks were tedious. The shipyard was more than a job. It was participation in national survival. Victory in the Pacific War was won by many people: the sailors who fought, the pilots who flew, the soldiers who invaded islands, all deserve credit. All contributed to victory. But behind them were the shipyard workers, the welders and riveters and electricians and engineers and managers and procurement specialists, the people who built the carriers that won the war. Their contribution was less visible, less celebrated, but equally essential. Without the carriers, the Navy couldn't have fought. Without the workers, the carriers couldn't have been built. The production achievement was as important as any battle victory. 15 carriers in 1943, built by workers like Casey and Williams and Henderson and Patterson, by managers like Ferguson, by thousands of people whose names are forgotten, but whose work mattered, who contributed to victory through industrial production rather than combat. Their legacy is the victory they helped create. The Pacific War won, the world saved from Japanese imperialism, the foundation laid for American naval dominance that continues today. The numbers tell part of the story. 15 carriers in 365 days. But the human story is richer, more complex, more inspiring. It's a story of ordinary people doing extraordinary things, of industrial mobilization on an unprecedented scale, of a nation transforming itself to meet an existential threat, and succeeding completely. Women welders became common. They welded hull plates, bulkheads, deck structures. The work was hard, hot, dangerous. Welding equipment was heavy. The sparks burned. The noise was constant. But the women proved they could do it as well as men. Rosalie Oswald worked at Kaiser Shipyards in Richmond, California. Started as a file clerk. Transferred to welding school. Became a certified welder in 6 weeks. Spent 2 years welding escort carrier hulls. Her work was indistinguishable from male welders, sometimes better. She took pride in her seams, made sure they were perfect. Black workers found opportunities in shipyards that were closed elsewhere. Segregation remained. Black workers often got the worst jobs, the hottest, the most dangerous. But they could work, could earn wages, could support families. The war economy opened doors that had been closed for decades. The pace was relentless. Shipyards operated 3 shifts, 24 hours per day, 7 days per week. Workers put in 60-hour weeks, sometimes more. The pay was good. Overtime was common, but the exhaustion was real. Accidents were frequent. Heavy equipment, moving cranes, falling materials. Men and women were injured regularly. Some were killed. But the work continued. The ships had to be built. The war demanded it. The transformation of American industrial capacity was visible in the numbers. Shipyard employment, 75,000 in 1940 to 700,000 in 1943. Carrier construction time, 36 months in 1940 to 18 months in 1943. Annual carrier production, 0 to 1 carriers in 1940 to 15, plus in 1943. Steel production, 66 million tons in 1940 to 90 million tons in 1944. These numbers represented millions of individual workers making millions of individual decisions to work hard, to learn new skills, to accept difficult conditions, to build ships that would win a war. The Japanese industrial transformation was different, less dramatic, more constrained. Japanese shipyard employment increased, but not by factors of 10. Japanese steel production increased, but not nearly as much as needed. The constraints were fundamental. Japan was a smaller economy, had fewer resources, had less industrial infrastructure. The gap between American and Japanese capacity grew wider as the war continued. By 1944, American industrial production exceeded Japanese production by factors of 5 to 10 in most categories. The disparity in carrier production was even greater. America was building 15 carriers for every one Japanese carrier. This disparity determined the war's outcome more than any battle, more than any tactical innovation, more than any individual commander's skill. Wars are won by nations, by economies, by industrial systems. The nation that can produce more carriers, more aircraft, more ships, more weapons, will eventually win, regardless of initial tactical advantages. Japan started the war with tactical advantages. Better carriers, better aircraft, better pilots, better tactics. They won the early battles through superior execution. But they couldn't maintain those advantages against American production. The carriers were sunk and not replaced. The aircraft were shot down and not replaced. The pilots were killed and not replaced adequately. The tactical advantages eroded steadily. America's advantages were different. Not better initially, but improving constantly, and backed by production that could absorb losses and keep fighting. By mid-1944, American advantages were overwhelming. More carriers, more aircraft, better training, better tactics learned from combat. The combination was unbeatable. The final statistics of carrier production tell the story clearly. United States carrier production, 1941 to 1945. Essex-class fleet carriers, 24 ships built 1942. 1 commissioned, Essex, 1943. 6 commissioned, 1944. 9 commissioned, 1945. 8 commissioned Independence-class light carriers. 9 ships built, all 9 commissioned in 1943. Escort carriers, 78, built by war's end. Total carrier production, 111, plus carriers of all types. Japanese carrier production, 1941 to 1945. Fleet carriers completed during war, 2. Taiho, Shinano. Light carriers completed during war. Approximately 6 escort carriers. Minimal production. Total carrier production, approximately 10 carriers of all types. The ratio speaks for itself. America built 11 carriers for every 1 Japanese carrier. The production advantage was overwhelming, but these raw numbers require context. They tell what was built, but not why the disparity mattered so much. Not how production translated into strategic dominance. Not what the human cost was on both sides. Let's examine this systematically. Production capacity analysis. American shipyard capacity in 1941. Limited. 3 major naval shipyards, Newport News, Bethlehem Quincy, and a few others. Total capacity. Maybe 2 to 3 carriers under construction simultaneously. American shipyard capacity in 1943, transformed. Newport News building, 2 carriers simultaneously. Bethlehem Quincy building 2. Multiple other yards building escort carriers. Total capacity, 8 to 10 carriers under construction simultaneously. The expansion wasn't just about building more yards. It was about expanding existing yards, adding building ways, installing cranes, training workers, developing supply chains, creating industrial capacity where none existed. Newport News. Shipbuilding expanded from 11,000 workers in 1939 to 31,000 in 1943. Nearly tripled its workforce, built new facilities, modernized equipment, became the most productive carrier yard in the world. Bethlehem Steel's Quincy Yard went through similar expansion, from building cruisers to building carriers, from one building way to two, from conventional techniques to modern mass production. The total investment in American shipyard expansion exceeded $1 billion, equivalent to perhaps $20 billion today. The investment was enormous, but it paid off in carriers produced by the dozen. Japanese shipyard capacity couldn't match this. Kure Naval Arsenal was Japan's largest, built some of Japan's best ships, but couldn't expand significantly. Space was limited. Resources were constrained. Investment capital was scarce. Yokosuka Naval Arsenal, Sasebo, Maizuru, all were operating at maximum capacity. All were building multiple ship types. None could specialize in carriers the way American yards could. The result? Japanese yards built carriers individually, one at a time, with long gaps between ships. American yards built carriers in series, multiple ships simultaneously, continuous production with no gaps. Construction time comparison: Essex-class average construction time, 18 to 20 months from keel to commissioning. Fastest, USS Intrepid, CV-11, 16 months. Slowest, USS Kearsarge, CV-33, 24 months. Delayed by changing priorities. Independence-class average construction time, 12 to 14 months from conversion start to commissioning. Fastest, USS Independence, CVL-22, 10 months. Slowest, USS San Jacinto, CVL-30, 14 months. Japanese fleet carrier average construction time, 33 to 54 months. Taiho, 33 months. Shinano, 54 months. The time difference was crushing. America could build 3 carriers in the time Japan built one. This wasn't because American workers were faster. It was because American industrial processes were more efficient, more streamlined, better organized. Mass production techniques developed in automobile industry. Assembly line methods, standardized components, interchangeable parts, quality control systems, all applied to shipbuilding. The results were dramatic. Japanese shipbuilding remained craft-based. Each ship was unique. Components were manufactured to precise specifications for that specific ship. Quality was excellent, but production was slow. Aircraft capacity and operational effectiveness sat in Essex-class Standard Air Group, 90-plus aircraft, 36 F-6F, Hellcat fighters, 36 S-BD, Dauntless or S-B-2, C, Helldiver dive bombers, 18, T-BF, Avenger torpedo bombers. Actual loadings often exceeded 100 aircraft during intense operations. Independence-class Standard Air Group, 30 to 35 aircraft, 24 fighters, 9 torpedo bombers. Taiho Air Group, 75 aircraft, 27 6M0 fighters, 27 D-4Y dive bombers, 21 B-6N. Torpedo bombers, Shinano Air Group, designed for 47 aircraft, but intended primarily as aircraft transport/support ship. Never operated an actual air group. The American advantage wasn't just numbers of carriers. It was aircraft per carrier, multiplied by number of carriers. Essex-class carriers each had air groups, equivalent to Japan's entire carrier force in late 1944. 15 American carriers in 1943 meant approximately 1,350 carrier-based aircraft. Japan's 9 carriers in June 1944 had approximately 430 aircraft total. The Americans had 3 times as many carrier aircraft, and those aircraft were better. Pilot training comparison. American Pilot Training Program, 1943 to 1944. Primary training, 60 hours. Basic training, 75 hours. Advanced training, 75 hours. Operational training, 50 plus hours. Total, 260 plus hours before joining Combat Squadron Japanese Pilot Training Program 1943 to 1944, shortened due to fuel shortages. Total, 100 to 150 hours before joining Combat Squadron. Advanced training, often cut short. The training disparity was as important as the aircraft disparity. American pilots arrived at combat squadrons with over 260 hours of flight time. Japanese pilots arrived with half that. The skill difference was enormous. American pilot losses could be replaced. Training infrastructure existed. Fuel was available. Aircraft were available. New pilots graduated monthly from training programs. Japanese pilot losses were irreplaceable. Training programs couldn't produce enough pilots. Fuel was scarce. Aircraft were needed for combat. The experienced pilots who died at Midway, at Philippine Sea, at Leyte Gulf couldn't be replaced. By late 1944, American carrier pilots averaged 300 plus hours of flight time. Japanese carrier pilots averaged 100 to 150 hours. Many had far less. The quality gap was decisive. Logistics and sustainability. American carriers operated with full logistical support. Fleet oilers provided underway. Refueling ammunition ships, resupplied ordnance at sea repair ships could fix battle damage. Escort carriers ferried replacement aircraft. The fleet could operate indefinitely without returning to port. Japanese carriers operated at the end of tenuous supply lines. Fuel was scarce, and getting scarcer ammunition resupply was difficult. Battle damage often required return to port. Replacement aircraft were limited. Operations were constrained by logistics. This sustainability difference was critical. American carriers could maintain operations for months. Japanese carriers had to conserve fuel, conserve ammunition, limit operations. The Americans could fight continuously. The Japanese had to pick their battles carefully. Battle loss ratios. American carrier losses in combat. USS Lexington, CV-2. Coral Sea, May 1942. USS Yorktown, CV-5. Midway, June 1942. USS Wasp, CV-7. Torpedoed. September 1942. USS Hornet, CV-8. Santa Cruz, October 1942. USS Princeton, CVL-23. Leyte Gulf, October 1944. USS Liscome Bay, CVE-56. Tarawa, November 1943. Total fleet and light carriers lost, 6 ships. Japanese carrier losses in combat. Akagi, Kaga, Soryu, Hiryu. Midway, June 1942. Shoho, Coral Sea, May 1942. Ryujo, Eastern Solomons, August 1942. Taiho, Shokaku, Hio, Philippine Sea, June 1944. Zuikaku, Zuiho, Chitose, Chiyoda. Leyte Gulf, October 1944. Shinano, torpedoed, November 1944. Total fleet and light carriers lost, 13 plus ships. The Americans lost 6 carriers total, replaced all of them and added 105 more. Net gain, 99 carriers. The Japanese lost 13 carriers, replaced 2 during the war. Net loss, 11 carriers. The fleet that started the war with 10 carriers ended with 0 operational. Economic cost analysis. Estimated cost per Essex-class carrier, $70 million, $1943, equivalent to approximately $1.1 billion in 2024 dollars. Total cost for 24 Essex-class, $1.68 billion, 1943. Total cost for 9 Independence-class, $450 million, 1943. Total carrier program cost, approximately $2.5 billion, 1943. As percentage of U.S. GDP in 1943, approximately 1.3%. American war production total, $186 billion, 1943. Carrier production, 1.3% of total war spending. The Americans built this carrier fleet while simultaneously building 175 major combat vessels, battleships, cruisers, destroyers, 203 submarines, 2,710 Liberty ships, 300,000 plus military aircraft, 75,000 plus tanks, 2.5 million trucks. The carrier program was significant, but it was a small fraction of total production. America had the industrial capacity to build carriers and everything else the war required. Japan lacked this capacity. Japanese war production total, approximately $40 billion, 1943 equivalent. 1/5 of American production. Every yen spent on carriers was a yen not spent on aircraft, tanks, or merchant ships. Resources had to be allocated. Priorities had to be set. Japan couldn't build everything it needed. Strategic impact of production disparity. The carrier production disparity determined Pacific War strategy from 1943 onward. American strategy could be offensive, aggressive, could accept losses, could sustain multiple simultaneous operations, could maintain constant pressure on Japanese positions. Japanese strategy had to be defensive, conservative, couldn't afford losses, could only concentrate forces for critical battles, had to husband resources carefully. This strategic asymmetry was visible in every campaign after Midway, Guadalcanal. Americans committed carriers despite high risk, could afford losses to gain strategic position. Marianas, Americans committed 15 carriers, overwhelming force that Japan couldn't match. Philippines, Americans committed 17 carriers. Japan's 4 carrier decoys was sacrificed uselessly. The production advantage had been translated into strategic initiative. America chose where to fight, when to fight, with what forces. Japan could only react, could only try to make American victories costly, couldn't prevent them. The human cost. Behind these statistics were human beings, sailors who served on these ships, workers who built them, families who supported them. American carrier sailors served in conditions that ranged from uncomfortable to dangerous. The ships were crowded, hot in tropical climates. The work was demanding. Flight operations never stopped. Damage control drills were constant. Combat was terrifying. But American sailors knew they were supported. Replacement ships were coming. Replacement aircraft were coming. Reinforcements were coming. The industrial machine behind them was powerful, unstoppable. This knowledge boosted morale, gave confidence. Japanese carrier sailors served knowing the opposite. Every ship sunk was irreplaceable. Every loss was permanent. The fleet was shrinking. Resources were dwindling. The future looked bleak. This knowledge affected morale, created desperation. American shipyard workers built carriers knowing they were winning the war. Each ship launched was a step toward victory. Each carrier commissioned was proof that America was overwhelming its enemies. The work was hard, but the purpose was clear. Japanese shipyard workers built carriers knowing it wasn't enough. Even Shinano, the largest carrier in the world, couldn't change the strategic balance. The production gap was too wide, the industrial disparity too great, the human cost extended beyond military casualties. It included industrial workers killed in accidents, civilians killed in bombing raids on industrial centers, families disrupted by war production demands. But the American cost was sustainable. The nation could absorb it, could maintain production indefinitely, could support the war effort without breaking the economy or the society. The Japanese cost was unsustainable. The nation was bleeding resources. The economy was strained beyond its capacity. The society was exhausted. By 1945, Japan was producing nothing, had no carriers operational, had no industrial capacity remaining. The war ended not because of atomic bombs, but because Japan had nothing left to fight with. The industrial war had been lost. The carrier production disparity was just one measure of that defeat. The legacy. The carrier production achievement of 1943 represents one of the great industrial accomplishments of the 20th century, building 15 carriers in 1 year, while simultaneously fighting a global war, while maintaining civilian economy, while supporting allies. The achievement required total mobilization, required transforming American industry, required training millions of workers, required creating supply chains from scratch, required solving endless technical problems. And it worked. The carriers were built, were commissioned, were sent to war, won battles, dominated the Pacific, made American victory inevitable. The legacy continues today. Many Essex-class carriers served into the 1970s. Some were modernized with angled decks and steam catapults, operated jet aircraft during the Cold War. The basic design proved so sound that carriers built for World War II served for 30 years. Some Essex-class carriers are museums now. USS Yorktown in Charleston, USS Intrepid in New York, USS Hornet in Alameda. Visitors can walk the decks, see the hangars, understand what these ships were, what they accomplished. The production lessons were applied to later carrier programs, the Forrestal-class supercarriers of the 1950s, the Nimitz-class nuclear carriers of the 1970s to 2000s, the Gerald R. Ford-class carriers of today. All benefited from lessons learned building Essex-class carriers in 1943. American naval dominance in the 21st century traces directly to the industrial mobilization of World War II, to the shipyards that built 15 carriers in 1943, to the workers who made it possible, to the industrial system that could produce weapons in quantities that overwhelmed enemies. Japan never recovered its carrier capability, built no carriers after 1945 until the Hyuga-class helicopter destroyers of the 2000s. The carrier tradition was broken, the industrial capacity was destroyed. The strategic lesson was learned. Don't fight industrial wars against nations that can outproduce you 10 to 1. USS Wasp, CV-18, commissioned November 24, 1943, served throughout the Pacific War, participated in raids on Truk, supported the Mariana invasions, fought at Philippine Sea, operated at Leyte Gulf, struck targets across the Pacific. Wasp survived the war, was never seriously damaged, served into the Cold War, was eventually scrapped in 1973. 30 years of service, from commission to scrap. The ship was one of 15 commissioned in 1943, one of the mass-produced carriers that overwhelmed Japan. Not special individually, but collectively overwhelming. Captain Joseph Clark went on to command carrier task groups, rose to Rear Admiral, retired in 1953, died in 1971. His career spanned from World War I biplanes to jet aircraft operating from carriers that displaced 80,000 tons. The transformation he witnessed was total, from 3 carriers in 1933 to over 100 in 1945, from inferior position to global dominance, from peacetime Navy to the largest fleet in human history. The production achievement represented American industrial capacity at its peak. The ability to design, build, and operate complex weapon systems in enormous numbers, to train crews, to support operations globally, to sustain combat over years. This capacity won World War II, won the Pacific War specifically. The battles were important. The tactics mattered. The courage of individual sailors and pilots made a difference. But the fundamental reality was production. America could build 15 carriers in 1943. Japan built 2 in 4 years. That disparity determined everything that followed. The Japanese knew this. Admiral Yamamoto had warned before Pearl Harbor that Japan could run wild for 6 months to a year. After that, American production would overwhelm Japan. He was exactly right. The timeline was almost perfect. 6 months after Pearl Harbor was Midway, Japan's last offensive success. After Midway, the initiative shifted. America advanced. Japan retreated. The pattern would continue for 3 years, until Japan surrendered in August 1945. The war was decided by industrial capacity, by the ability to build carriers faster than the enemy could sink them, to build aircraft faster than they could be shot down, to train pilots faster than they could be killed. America could do all of these things. Japan couldn't. The mathematics were absolute, brutal, inescapable. 15 carriers in 365 days against 2 in 4 years. The outcome was determined by those numbers more than by any battle, any tactic, any weapon system. America built carriers. Japan couldn't match the pace. The rest was inevitable. That's how the Pacific War was won. In shipyards in Virginia, Massachusetts, and California, by workers welding hulls and installing equipment, by engineers designing systems and solving problems, by managers organizing production and meeting deadlines. The battles were fought at sea, but the war was won in the shipyards. The numbers prove it. But the numbers alone don't capture the full story. American carriers were more capable, better armed, more survivable, better equipped with radar and electronics, supported by better logistics, maintained by better infrastructure. Japanese carriers, while often excellent designs, operated at the end of increasingly tenuous supply lines. Fuel was scarce, replacement aircraft were limited, spare parts were hard to obtain. The carriers couldn't operate at full effectiveness even when available. The Battle of Cap Engano in October 1944 demonstrated this. Japan sent 4 carriers as decoys during Leyte Gulf. The carriers had few aircraft, limited fuel, minimal effectiveness. They existed primarily to be sunk, to draw American forces away from the main operation. All 4 were sunk, as intended. But the sacrifice accomplished nothing. The American forces were so overwhelming that even with carriers drawn off, the remaining forces destroyed the Japanese fleet anyway. This was the reality by late 1944. Japanese carriers were so outmatched that their primary value was as targets, as distractions. The carrier force that had struck Pearl Harbor had been reduced to decoys. American carriers, by contrast,